This conference will now be recorded.
Okay, so we will discuss today fault analysis.
Ishfaq bhai, your voice is not clear.
I'm not able to receive the voice.
it stands
Yes,
for Hazards and Operability Study.
Ishfaq bhai, your voice was not clear. I think you are speaking, but we can't listen the portion. Please repeat all the things.
Okay, now my voice is clear.
Yes, now is clear.
Today we'll study hazard study, fault analysis, event analysis, and maybe hazards, preliminary hazard analysis. Okay, hazard study and these four other techniques are using for the failure tracing, or you can say where the system will fail and how we will identify that system. First of all, we will study the hazard study. Hazard stands for hazards and operability study. This system is used for the complex processes, and you can say for the nuclear system, oil refineries, where the process is involved. We are using hazard study for that. In this system, we will use some specific words like 1 minute. Not, no, and not, more, less, as well as part of, reverse, and other than. Okay, in this study we will study the control the parameter of the process, which is contain the flow rate, temperature, pressures, and other parameters we will study later. Once we study the diagram, then it will be very clear to all of you. First of all, we will divide the system in different parts, which is called nodes. What? Nodes. After that, we will identify the hazards with each nodes. Okay, and then we will provide the controls. This is a simple 3-4 step process. Okay, and we will check for the temperature, we will check for the flow rate, and we will check for the pressures. And let's suppose if it's increase, if it's decrease, there is no pressure, there is no water flow, and what is the root causes for that, we will discuss in this study. Okay, and in this study that's okay. This study, uh, this is not a simple process that one person will sit and he will do the hazard study. No, this is not possible. In this study we need to bring safety experts, we need to bring the software engineer, we need to bring the automations person, we need to bring the electrical engineers, mechanical engineer, chemical engineers, instrumentation engineers, who are involved in the design of the system and who know how to every part of the system. Every engineer should be there for this study. Okay, this is not a simple process that one person will do this. After that, once the team, you prepare the team, this is a recorder, a designer, every person. Okay, this is the and study leader. Once you develop this team and they sit for the hazard study, then we will divide the system. We will select one system for which we are doing the hazard study. We will divide that system in different type of parts, which is called nodes. Okay, after that we will identify the hazards with each node, and then we will provide the control. Okay, once we divide the process and nodes, then this is the principles, main words which we will use for to make our study easy, because we cannot write their long sentences, etc., etc. No, not no flow. Yeah, there is no pressure. More flow, there is more temperature, more pressure. Okay, less flow, less temperature, less pressure, and as well as for parallel system, etc., etc. We will study this later. Now, this up to this point, it's clear to all of you.
Ishfaq bhai, these guide words are generic or universal, or maybe change process to process, or maybe change or industry to industry, or it is
No,
universal, yeah, generic.
this is only a generic words for no need if you are not using this, but this to make our study easy. Because if there is, let's suppose, no flow, so for the no flow, what you will use there? No flow. Okay, if the temperature is less, so is there if there's any alternative words, you can use that also, but this is no, you can say the generic words which we are using in the hazab study.
Okay.
Okay, let's suppose if the flow is more, so for the more, what other word we can use? This is the easy and generic words which we can use for the more flow and less flow, etc., etc.
Okay. Okay.
Okay. Okay, now here is the simple system which we will study and for our hazab study. Okay, it's clear to all of you. This system is the reactor vessels only, and two flow rates, two pumps are involved, which is filling this reactor tank. This is a very basic and simple system. Okay, can you people listen to me?
Yes, yes,
Yeah,
Ishfaq bhai,
Ishfaq.
carry,
Yeah, Galas.
carry on, carry on.
Yes.
Yeah, yeah, please carry on.
Now, okay, now first let's suppose this is a very simple system. Okay, uh, here this is one storage tank, this is another storage tank. The, let's suppose, water or chemical flow line is coming to these two pumps. Okay, and it takes the any chemical or water to this reactor. Okay, here are the two stream lines. Now we will consider the flow rate. Let's suppose uh, here the flow rate of the pump, there is no flow in this system. Okay, system A, pump, no flow. Okay, so for the no flow, what is the causes? First number, maybe this pipe is choked. Okay, maybe one, the reason should be this one. Other reason, maybe the pump is not working. Okay, second reason, maybe the pump, someone did not switch on the pump. Either the pump is damaged or someone did not switch on the pump. Okay, maybe this line is choked. Okay, and maybe storage vessel air don't have the fluid. Okay, water or other chemical. So this is the reason for the no flow. Okay, in streamline 1, same like for this streamline. If here is the no flow, maybe this line is choked, maybe this pump is not working, maybe this line is choked, maybe here no fluid in this vessels. Okay, now this is the causes. Now how we will make, let's suppose, how we will identify this causes. This is the reason. Now there is automation engineer, there is other engineer, mechanical engineer, and they will say that if there is no flow, maybe this is the reason, maybe this is the reason, maybe this is the reason, or this one is the reason. Okay, now we need to provide control. How we will provide the control? Let's suppose for this pipe, if there is no flow, we will install here one pressure gauge and one pressure gauge here. Maybe also there is, this tank is full. If this tank is full, maybe here is the no flow. Okay, this is also one reason. So we will install here pressure gauges. Okay, one at this point, one at this point. Now Let's suppose if this line is choked at the middle, okay, so this pump is pushing the fluid, but the fluid is not going here. So here the pressure gauge will have more pressure, and this will have the reactor pressure. Okay, this here, let's suppose I cannot draw now here because this is PDF, so I cannot draw here the diagram. Here we want one gauge and here another gauge. Okay, so if here is more pressure and the pump is trying to push the fluid, but this line is choked. Okay, so here definitely this pressure gauge will show more gauge, more pressure. Okay, more reading, and this pressure gauge will have less reading. So definitely we will know that this pipe is choked here. Okay, now for the pump, let's suppose if the pump is not working. So if the pump is not working, all the system will have zero pressure. Okay, and let's suppose if someone did not switch on the pump, so for that we can put one operator, he will check that. Maybe we can make it automation, we will install some sensor. Okay, let's suppose if the pump impeller is not working, so the pump will run and impeller will not work, it will not push the liquid. So this is the two pump reason for this. We need to make automation for this. Let's suppose we need to install some sensor for this to make it automatic. Let's suppose if we need the pump to switch on, so it will automatically switch on the pump. Here, let's suppose if this line is choked, so we will install one pressure gauge here, another pressure gauge here. Now, let's suppose the line is choked here, so the pump will suck the fluid. Okay, so here after this pressure gauge to this area, the pump is sucking, so that the pressure will be reduced till the choking, from the choke point to this pump point, because the pump is sucking. So here the it will show the reduced pressure, and here the from this gauge, from this storage tank to this, because here is the fluid is coming by itself by the gravity. So here this pressure gauge will show a little bit more reading. Okay, so this is for the no flow. Now we can, let's suppose, check downside what they are saying. Okay, design intention. What will be the intention? Design intention are those for which the system is designed. Okay, let's suppose if the system is not functioning properly, then we will call it deviation from the intention. Okay, if the system is not working properly according to the design parameters, so that is called design intention. If it's not working according to the design intention, then we will call the deviation from the intention. Yeah, simply deviation. Okay, now storage A and 5 line. Okay, this is the simple. Okay, let apply for no. Okay, so what is the reason? Now see, here are some suggestions. Pump A has failed. Pump A not switched on. Storage vessel A is empty. Okay, reactor vessel is full. Okay, okay, reactor vessel is full. Now let's suppose if the reactor vessel is full and here no fluid here in this, so how we will identify this? For this we will install here level. Okay, maybe some this sensors available which sensing the level of this reactor. Okay, and simple for this, which we are using in the domestic levels, we can install here 1.5, but this reactor we cannot. I'm just showing only for your just for make it simple. We can install here one pressure gauge which will show the level of this tank, but this is not applicable. We need to here install some automatic level gauge which show the level, so it will show us the more level. Let's suppose if it's reached to its design level. Okay, after that it will send the signal to the pump that you should stop it. So once it stop, because the desired level is reached. Okay, now let's suppose the reactor reached to minimum level, or the reactor become empty, so this pressure will sense that the level is very low, we need more flow now, we need flow from pressure pump A and pump B. So it will send the signal to the system, and the system will switch on these two pumps, and it will give the fluid to this reactor vessel. Same here for these two vessels. We will install the level level meter. which will show the level of these gauges. So we solve here for the flow system. Now let's suppose if there is no flow, all the system is now automatic. We will know about the no flow reason, the causes. So and we provide the control for this. Okay, now let's suppose here temperature, we are considering the temperature. Okay, temperature mean here let's suppose we have one system. Okay, and a reaction is occurring here, and the reaction is exothermic. Okay, mean it gives the reaction, it gives the heat. Okay, once the reaction is occurring, it gives the heat. Now let's suppose in the reactor we have more heat, more temperature. Okay, so if the temperature is more, what will happen? Yeah, if the temperature is more, what will happen? This is exothermic reaction, so the reaction will stop. Stop, or the rate of reaction will reduce, because here the reactor have more heat. Okay, and if let's suppose less heat, so the reaction will become fast. So for controlling the temperature of this reactor, what we will do, we will install here one sensor, which will we will monitor the reaction of the temperature of the reactor inside. And after we let's suppose to control the temperature, we can install here some water jacket or some other cooling chilled water. We can we can install some coiling system here, some cooling jacket around the reactor, which will take the heat from the reactor. Also where we can install the tubing system here, inside that tubes the cold water or some cold fluid or some cold refrigerant will move, and it will take the heat outside from this reactor. So this is for the temperature. Let's suppose if it's more temperature, then we need to install here one temperature sensor, and we need to install some cooling system. Let's suppose you install the cooling system also, and still there is more temperature. Maybe your cooling system is not work. So for that cooling system, you need to again do the hazard study. What is the reason? How we can control that reason? Now it's clear.
Yes, clear.
Okay, and let's suppose what is the consequences. Now let's suppose we will just move toward the chemicals, pump A and pump B. For the optimum reaction, let's suppose this is the design parameter. Let's suppose, okay, from pump B we need 2 gallon per minute, and from pump A we need 1 gallon per minute. So 1 gallon is coming from here, 2 gallon is from here. Then your system is working, your reaction, this reaction yield is less, and this is optimum reaction. If 2 gallon is coming from here and 1 gallon is coming from here. Now let's suppose more flow from pump A. So let's suppose two here is okay, but here from instead of 1 gallon we are receiving 2 gallons. Okay, so here you can say that 1 gallon of pump A per minute is increasing. With each 1 minute 1 gallon is increasing, so the precipitation of A will be more, and it will affect your reactions. So how we need to control the flow rate of pump A? We need to install here one flow meter, flow measuring controlling device, flow meter. That flow meter will sense the flow of the pump A, or the streamline A, and there should be one flow controller valve. This is automatically valves are available, and that flow meter will give the signal to that flow control valve or flow controller, and it will control the flow of pump A. Okay, so all these factors we need to consider in the hazard study. More flow, less flow. For the, let's suppose we are doing for the chemical plant, this distillation tower in which we are doing the distillation of the oil refineries. So in that cases, the flow, temperatures, pressures, they are very very important. Deviating from the design intention will cause maybe very big losses, maybe big accident. Okay, so in that cases, that it become very complex. For that we need to study the PID diagram, process and instrumentation diagram, but that is not necessary for our exam. For our exam, it's only necessary we need to understand these design intentions, and how we need to control the flow, how we need to control the temperature, etc., etc. No need to go for the more detail. Okay.
Okay.
Now, any question?
No, no, it's right. Very nice.
If anyone have some questions, some confusion, no problem. We can go for a little bit more detail. But this is only a simple system, very simple system, which is very clear to all of one, that how let's suppose to control the flow and temperature. And for that we need to study a little bit chemistry. Let's suppose if any reaction is occurring. Okay, let's suppose we'll go for pressure. In the reactor we have more pressure. Okay, so what we will do, maybe the reactor design pressure, let's suppose 10 bar. Okay, and the pressure is increasing to 9 bar, and the set, the set limit is, let's suppose, 8 bar, and now the set limit is increasing. So what we need to do in that case, we need to install here, pressure release valve. Okay, so that pressure release valve should be set at 7 bar or 6 bar. Okay, so it will release the pressure. Second, all of you, maybe if you study the chemistry, you will remember the Le principle. There was one principle which is called Le principle, that is using for the uh, two-way reaction. Let's suppose we have one reaction from A plus B, is equal to, and coming backward and forward reaction is occurring C plus D. But here the molecule is more, here the molecule is less. What mean? Okay, I'm just checking one reaction from the Google. Now it's visible to you. Here, let's suppose we have this reaction. Okay, and this is, let's suppose, exothermic reaction. Okay, so what will happen? And here, let's suppose we will add 1 2 here, or we will add 4. So if the pressure is increasing, and here this side molecule is less, this side molecule is more. So if the pressure is increasing, the reaction will go in forward direction, so the product will become more. If the pressure is reducing, the reaction will go in backward direction, so the product will reduce and the yield will become more. Let's suppose if this is exothermic reaction, mean the reaction is occurring here plus temperature. Okay, plus heat. So if the temperature is increasing inside the reaction, your reaction rate will become reverse. Because here it gives the temperature, and there is excess of temperature in the reaction. Okay, then the reactor. Okay, so what will happen? The reaction rate will become slow, and this will move in backward direction. So your yield will be more, and your product will be less. So here in this reactor, let's suppose if this is exothermic reaction, mean after the reaction it give its own temperature. You need to take that temperature outside, so that the reaction and the vessel become fast. If the temperature is yielding inside, okay, and you are not removing that temperature outside to the environment, or you are not applying the cooling jacket, so what will happen? Your reaction rate will become slow. So this is we need to install here then temperature sensor, and we need to install here the cooling jackets. Okay, so it will take the heat outside, and your reaction rate will become more. So now it's okay.
Yes, yeah, okay.
Any question? Okay, here let's suppose pump failure. I forgot here. Let's suppose if your pump is failing. Okay, so what we will do here, we need to install one bypass pump. Okay, if we install one bypass pump, so what will happen? Let's suppose if your this pump is not working, the bypass pump will start automatically working, same like you are applying here. Once we are installing the firefighting system, we are installing one diesel pump, one electrical pump. Let's suppose during the emergency your electrical pump is not working, so we will start the diesel pump. So two system, this is called fail active or a redundant system. This is called redundancy. If you install here the second pump, here this word is also here redundant. Okay, yesterday we discussed that what is redundancy. So this is a redundant if we install another pump, so that is called the system redundancy. So the probability of the failure of this system will reduce. Okay, can we move?
Yes, yes.
Now we will discuss the fault tree analysis. Okay, here in this book the fault tree analysis is a little bit simple. Here first we will discuss here, then if you want to go for detail we will discuss from the other book. Okay, so what is fault tree analysis? Fault tree analysis system are techniques which we are using for identifying the failure of the system. Okay, this will start from the main event. Let's suppose main event is what the fire occurs. So the main failure. Okay, so from the failure we will make branches, and their branches will divide to sub other branches. Okay, and and between that branches we will insert a different type of gates that is called logic gates. That logic gates we will discuss later, that what is the function and what they are, how they are operating, how they are working. Okay, some are called or gates, some are called and gate. For we will interest our study, mainly it will revolve around the AND gate and OR gate. Okay, here the undesired event. Okay, this side which is coming, all the event is coming toward the main event. This side is the fault tree analysis. After the fault tree analysis, this is called event tree analysis. We will discuss later because this is only a general diagram. Once we combine both the fault tree analysis and event tree analysis in one diagram, then it is called bow tie analysis. Okay, here the initial event and the fault tree analysis will be our starting point. Okay, now the final event will be the starting point. Okay, so this side is fault tree analysis and this side is event tree analysis. Fault tree analysis, generally it will give us the failure. Okay, and event tree analysis will give us the events or the consequences of that accident. Okay, now understand, you these two terms should be remember that fault tree analysis is used to identify the failure and event tree analysis is used to identify the consequences or the events after the accident. Okay, this event, this study is using for the preventive measuring. Okay, and this is the mitigation. Let's suppose if the accident occur, how we will then mitigate the losses, and faulty analysis as the preventive measure. Okay, before the accident what control measure we can put and what will be the failure events and what how we will protect, prevent the failure after the accident occur. Then mitigation is a mitigation measure. Okay,
Okay,
it's clear.
Ishfaq bhai, yes, it is clear. However, we can use separately these, or we can use it combinedly.
No,
If we
we can
investigate
use
some,
yes,
okay,
yes.
if we
We can,
investigate one event, and we can use only the causes, know-how about the causes of that event. So we use only the fault tree analysis, or even we will use the event tree analysis as well.
yes. Let's suppose if you want to check for the failures, then you need to use only the fault analysis. Okay, and if you want to know the consequences and the results of that accident and how we need to mitigate that, then you need to use, you can use it separate also, the inventory analysis. Okay, this is separate analysis, this separate analysis. But if you are making the
Okay.
same, then it's called bow tie analysis. Bow tie analysis, This is only the combination of the faulty analysis and the inventory analysis. Here you see a relationship between faulty analysis and this is called the bow tie analysis. Okay.
Okay. Okay.
Now faulty analysis, we will just go for the faulty analysis. Wherever you see this rectangle, this is the main event. Okay. Main event will be identified by the rectangle. This type of shape, the D shape. Okay. This D shape is the AND gate. For the AND gate, the output event will be occur if all the input event occur, then the output event will occur. Okay. Let's suppose here are three events. If one of them is not occur, still this event will not happen. If all the three events inside to this AND gate occur simultaneously, then the output event will happen. Okay, this is the purpose of the AND gate. Now OR gate. What is OR gate? Let's suppose we have three input events here and one output. OR gate mean this is a parallel system. Any of the input event occur, the output event will happen. Okay, same like let's suppose parallel, we have one circuit, in parallel circuit. Okay, parallel circuit will fail, the circuit will disconnected if all the three lines fail, then the voltage will disconnected. But let's suppose any of the three branches, any of the three from the branch is working, then the voltage will be there. If you want to draw some, let's suppose I will show you one minute. Okay. So it's visible to you? Hello?
Yes. Yes. Yes.
Okay. Now let's suppose here we are moving. Okay. 1, 2, and 3. Okay. Now current is coming from here. Okay. And it's going here. Okay. Now this is the system redundancy. Now let's suppose here the current is failing, no current. So what will happen if this circuit is broken, this circuit is broken, and this circuit is broken? Okay, then there will be no current. Same like here. Okay, if this one is happen, this one is happen, and this one is happen, then the output will happen. Either you can say like this, when here the current will come. Okay, if any of the circuit is working, the current will be here. Okay, the circuit will be completed. Okay, here the current is coming from here. If this is not working, this is working, so the current will come here. If this both are not working, then the current will flow from here. Okay, if this one is also not working, then there is no current. Okay, so if any of the circuit is working, the current will come to the main point. Okay, so this is the OR gate. AND gate is series gate. Okay, AND gate, series gate. Let's suppose here we have one button here. Okay, one button here. Okay, and one button here. Okay, AND gate mean series. This should also be switched on, this should also be switched, this should also be switched on, and this should also be switched on. Then the circuit will become completed. Okay, and the current will come here. Now it's clear. This is the purpose of AND gate, and this is the purpose of OR gate. Okay.
Okay. Okay.
Basic event will have the probability of 1 every time. Okay, and basic event should not be extend more. This will be the final basic event. 1 minute, just give me 2 minutes. Okay. Okay, basic event will not further be extended. Okay, and we will discuss in the system, then it will be clear to you how the basic event is there, and the probability of the basic event will be 1. Now here in this system, fire is the main event here. Okay, now fire is occurring. Okay, so what is the main causes for the fire? We also know the fire triangle. Okay, fuel, okay, oxygen, and ignition sources. Okay, if these three are here, then the fire will occur. So if any of the three is missing, okay, if fuel is missing, or oxygen is missing, or ignition source is missing, then the fire will not occur. Okay, so for this we will use AND gate. Okay, now if fuel is there, oxygen is there, and ignition source is there, then if all of the three is there, then the fire will occur. Okay, now for the fuel, what will be the main reasons? Either the fuel should be petrol, okay, either it should be plastic, or either it should be paper. So if any of these three are there, okay, then it means the fuel are there. Okay, clear? Hello?
Ishfaq bhai, it is seem like that the end gate and the OR gate is like a branches of end gate. Like the fuel has three
No.
now
Yes.
branches. Now the event has three main events, and ignition source has three main events, and gates and
Yes.
two OR gates. Yes, it is right
Yes.
logic, which
This is
I am thinking.
no, no. It doesn't mean that there should be always A and gate. Sometimes here should be also R gate, but it depend upon your event. Now here is the fire event. So for the fire event, here should be the A and gate, because fire will never start if these three things are not there. If there is no fuel, if there is no oxygen, if there is no ignition source, there will be no fire. So for this case, we will install here one AND gate. Okay. If you forgot the symbols, it doesn't mean that it should always be the same. You can also write here AND. Okay. So fuel and oxygen and ignition source, this should be must there. Then there will be a fire. Now where you can find the fuel, find the fuel. Either it should be a paper, or it should be a petrol, or it should be a plastic. Okay, or it should be maybe some other thing. Okay, clear? Ignition
Okay, now
source
clear.
from, okay, where from the ignition can come from. Okay, maybe it will be a cigarette, maybe it will be an electrical fault, maybe someone deliberately do the fire. So if any of these things are present there, it means there is ignition source. So here should we will use the R gate. Now clear?
Yes, yes, now clear.
Okay,
And we can again
now yes.
we can say that the and is the or is the or basically or is all the justification of and is the justification of that event. Means justified, yeah, means I am understanding, but I am not
No,
telling you
no,
about that.
there is a
Yeah.
don't, no, no, don't confusing yourself, from the extra words. This is simple R gate. Here,
Okay.
the purpose of the R gate is still this point. After this is another event. Okay, we will just consider the purpose of every gate before and after only. Okay, after this, what is happening, this is not the concept of this gate, because if this there is fuel, this function is khalas. Okay, then other event should be there. Now this is the fuel, this is the main event for this gate. Okay, if this is the fuel, till this point it's function khalas. Okay, finish. After this is another process. This is only a simple system, okay, because if you are doing this for the complicated process, it will go for the multiple pages, and for that we are using some other, diamond diagram. That diamond, and there is some other triangle, which, let's suppose, if here the page is finished, then we will just put here one triangle, we will take one bar to another page, and from that page it will start. Even this one branch go extend very far, because for the complex system there are multiple reasons and there are multiple causes for the accident to happen. And this is only simple a fire, because generally we are discussing a fire, and if we start from the complex system, then it's not understandable. This is a simple system, and only this type of system, we can consider. In the exam you will just find only this type of event, okay. For that they will ask you the cut set, that what will be the minimum cut set to occur this event, okay. So
Okay.
in the exam they will just give only this type of example only, not the bigger one. This is only just for the understanding of the gate and the XR, and the AND and the OR gate, okay.
Okay. Okay.
Now, okay, we need to convert it to, that this was qualitative analysis, okay. We are just, discussing only the words. Now we need to convert it into quantitative analysis, okay. Now you just discover from your study that the probability of the paper in your warehouse is 1, the probability of petrol is 0.00 and the plastic is 0.9, okay. Here for the discrepancy, because some people are smoking there, so the probability of the cigarette should be, maybe it's up to your study is 2. This is only a supposition, okay, not exact value. Fault, electrical fault at 0.5, and deliberate maybe 0.1, okay. There is some, Alibaba person in your company who may just deliberately can do this. Now for the OR gate, remember, for the OR gate, always the output event, it should be greater than the input, so we need to add all these. 1 0.1 plus 0.02 plus 0.9 we will put here. So the probability of this event will be plus this, this one plus this one and plus this one. This is for the OR gate. For the AND gate we will multiply all the thing. You need to remember this, okay. This is important because here is no logic. For the AND gate we need to uh, multiply it, and for the OR gate we need to add. Why we are adding? You see here, if any of these three things are present, the output will occur, okay. So here the probability is more, okay, so we need to add all these three. Here all the three should be happen at a time, then here the probability, the this event will occur. So for that we need to multiply this. This is the probability logic. For this we need to read the reliability and probability statistic, okay. But here, you people, we need to remember only that for the OR gate we will add, for the AND gate we will multiply, okay. So see here, now we will add in the next diagram. Here we add, okay, 0.01, 0.02 and 0.09. It will give you 0.21. Here see, the output is greater than the input, okay. Here also we will add 0.05, 0.2 and 0.1, so it becomes 0.3. And for the main this event, it should be 1, okay. Now for the OR gate, this is AND gate now. So for this we will multiply it. So what will be the probability of fire? Now see, 0.21 from this side and 1 this one, and 0.35 from this. So the probability of this system to occur the fire is 0.0735. Now it's clear.
Yes, clear.
Okay. So what does it mean? 0.07. It means that let's suppose if it's occurring one per year, so we need to multiply that 0.1 with this one. It will give you, let's suppose if this event in your system is occurring once a year, so what will be happen, we need to multiply that with 1 year, then it will give you 0.0735 divided, 1 divided by this, so it will give you that after how much year this event will occur, this type of losses will occur. This it will be clear to you. We will discuss this event reanalysis. So in that system it will be clear to you that how we are converting this to per year. Simple, we need to divide 1 by this. Okay, if it's per unit, so 1 divided by this, it will give you the exact value. Same like here, you see, if it was say that 0.25, then represent 1 by, okay, 4. So let's suppose if it's quarter, then it should be 4 times. And let's suppose if it's this one, so it should get 13.6, nearly 1 and 14 chances. Mean that if 14 chances occur, okay, 14 chances of these events occur, maybe there is a chances of 1 fire. Okay. Hello.
Yes, yeah, Ishfaq bhai. It's okay. Very nice. It's okay.
This final term is okay now.
Yes, yes.
Yeah, we need to divide it by 1, so it means that in one, if in one charge this much, so okay, so now we need to convert that. How? Let's suppose if we divided this 1 by this, it will give that, let's suppose if 13.6 chance, 0.6 is not occurring, so 14 chances. If 14, 1 fire will occur and 14 chances. Okay, this event occurring 14 times, there will be 1 fire. So this is the quantitative analysis thing. Now in this system, we study that where is the failure and what is the main causes of fire. Okay, so it just reached the fire. Now we will discuss after the fire, that after the fire what will happen. This is called event reanalysis. It will give you the events. Okay, here this will be the initiating event, the final event of the accident is the final event. So for this, the initiating event will be the main accident. Initiating event, let's suppose the fire detect or not detect. If yes, then we will go for further control. If no, then we will go for the consequences. After no, let's suppose if fire detected, okay, what is happening next? If no fire detected, then you need to go for the consequences. Let's suppose if your system failed to detect the fire and there is fire in your system, so what will happen? All the thing will burn. You will go directly for the consequences. Now there is a fire, but your system detects the fire. Okay, now the fire is detected. Now we will discuss this later. So all this event is basically give you the consequences of the accident, and this event will just based on yes and no. If yes, what we will do next? If no, just go directly for the consequences. Okay.
Yes. Okay.
Okay, now let's suppose there is a fire. Okay, after the fault analysis, we provide all the controls, but after 14 chances, 1 fire occur. Okay, now 1 fire occur. Now the fire detected or not? Okay, now the fire detected or not? Let's suppose here this is 1 fire detected. There is a question mark. Detected, yes or no? If yes, we will go for further branches. If no, we will go directly for the consequences, that what is the possible damages. Okay, possible damages may be your property, maybe the employees, maybe some money, maybe other things. Okay, so we will consider the possible damages. Okay, now let's suppose the fire is detected. Okay, fire is detected, the sensor work that there is fire. Now it send the signal to, we discussed the central unit system. Okay, fire alarm, FAUC. Okay, C or sorry, so it detect the fire. Now it sent the system through which did you remember we discussed that what signal now is working? Remember? I'm just asking, you forgot. There are three type of signal, and supervisory signal, alarm signal, and one is
Yes, suppression or extinction.
no.
Third one.
Once last time I just discussed this the fire alarm system. There were three
Yes, yes.
signal: supervisory signal, this alarm signal, and one was
Proprietary? Proprietary?
yes. Now the signal will go through alarm system. So now the alarm is working or not. Let's suppose the alarm did not work. So directly we will go again for the consequences. Okay. Now the alarm also works. Now the system detect the fire. Alarm also start ringing. Okay, that there is a fire. Okay. After the fire, now alarm system yes or no. If yes, we will go for further control. If no, just directly go for the consequences. Okay. Now yes, so first we will come to the no. Okay. Now fire alarms also works. The alarm start ringing. Now what should be the next step? Now the people inside the property or the building get alerted that there is a fire. Now after that, what should be the next control? Either the sprinkle works or not. Okay. If yes, this is our final step now. If the sprinkle work, yes, so the damage will become limited. If let's suppose the fire detected, fire alarm works, but the sprinkle did not work. So mean there will be extensive damages, okay, because your suppression system did not work. Only alarm worked, people just evacuated from the building, but sprinkle did not work. So we will go for the consequences. What is the extensive damages? Okay, here now, after the alarm did not work. Okay, so now maybe the alarm did not work, but the sprinkle system work here because this is coming under the sprinkle system now. Okay, maybe the alarm have some problem. It give the signal, the system giving signal to the alarm, but alarm is not working. Maybe some dysfunction, it's not working, but it send the signal, the system send the signal, but the alarm may have some problem. So it's not working. So also the system send the signal to the sprinkle system, the sprinkle system will start working. Now what will happen? The people which is inside the property, if they become wetted, maybe there is a chance here, because this is only a possibility, that maybe the people who just wetted, they will not catch fire easily. Okay. So and other people who are not wetted, so we will go for the consequences here. Now this is a little bit understand you people.
Yes, yes, understand.
Yeah, this is event analysis, which discuss only the events and its consequences. It will be based only on the yes and no word, and it is using for the mitigation control measure. After the accident, what we will do and how we can reduce the losses. This is a proactive reactive. No, you cannot say this is a reactive system, but it's after the accident what control measure is now working. Okay, because if you are installing the fire alarm system, this is a proactive system. But here let's suppose in this event analysis, this we will consider all the events which is happening after the accident. Now it's clear. Any question? I need your input, because if I'm just speaking in we should talk
No,
with
no,
each
yes,
other.
yes. Yes. Basically, now what will happen that the in fire is occurring, and now in the event analysis, we are now seeking the recovery and the damages or
Damages.
consequences,
Yes,
and we are estimation the
exactly.
consequences. Okay, so
Exactly.
if we use these both, so we can use a bow tie analysis.
That
So,
will correct both analysis.
okay, okay, okay.
Okay, now we will convert this to quantitative. Okay, how we will convert the probability of each branch. What will be the
Okay.
probability of this branch? What will be the probability of this no branch? What will be the probability of this branch and this one and this one? Okay,
Okay.
all this this explanation of the same thing which I discussed with you. Now see here, the two branches, sum of the probability, probability. What is probability? The chances of occurrence is called
Yes.
probability. Okay,
Frequency of
no,
event
no,
occurring.
frequency is something else. The chances.
Okay. Chances.
Frequency
Okay.
mean, frequency mean a thing is happening again and again after certain time. That is called frequency. But this is probability. Probability means chances of a thing which, chances of success and chances of failure. That is called probability. Okay, let's suppose here is what is the chances of success, because you install the fire detector and maybe there is in the fire detector, they are just putting that what is the probability, reliability of the system. So that reliability of the system give you the chances of success. Okay, probability of failure and probability of success. For that we need to study one chapter from the Roger L. Brewer, which is totally regarding the reliability of equipments or something. I think its name is reliability. So we need to study that chapter. Then this topic will be very, not this one, the probability of success and failure, all the thing will be very clear to you people. But here the probability of the two branches should be always 1. Okay, here you see 0.95 and 0.5. Here 0.99, 0.01, 9 and 1, 9 and 1. Okay, the probability of yes and no, the sum of the probability of yes and no should be 1. Okay, now the fire is occurring, the chances of fire is 0.1% per year. Okay, 0.1% per year. Clear?
Yes.
You will start from 0. Okay, now
Yes.
let's suppose 0.1 chances of fire per year is there. Now you install one system, the fire detection, fire alarm system, fire sprinkle system. Now the detection probability of detection, the reliability of system is more. This is 0.95. This is the probability of success of your fire detection. Okay, now it's detected. Okay, I think we need no need to repeat again the same story, yes and no. Okay, then the fire alarm work or not? If yes, so the fire alarm probability of success is 0.99. Okay, if it's work, then the sprinkles work starts, or it start works or not. Now the success of the sprinkle system is 0.9%. Okay, 0.9. Clear? Mean 90%. Okay, 0.9
Yes.
not a percent. This is the probability. So this means 90%. Okay, here this is 99% and this is 95%. Okay, because we need to multiply it by 100. Okay, so then it will convert to percentage. So the probability of two events should always be 1. Okay, so here's 95%, 90%, and 0.9%. Now what we'll do, let's suppose if we are going toward this branch, so we need to multiply each branch with. Let's suppose we are going toward by this way. Okay, we need to multiply all these 4 events with each other. It will give you that the chances of this much damage will happen in how much year. Okay, if we are coming toward this way, this one, let's suppose this is number 2, extensive damages. We need to multiply all these factors. Okay, all these probability, then it will give you the chances of this much damages. Okay, extensive damages, and how much here. Okay, and same we can repeat for others. Okay, now you see here,
Yes.
let's suppose where is it? Here the first one, okay. We need to multiply the fire frequency 0.1 per year, okay. Then fire detected, that was 99%. Then fire alarm works, that was 99%. This was 95%, okay. And the sprinkle works, that was 0. Must mean 90%. So it will give you one factor, okay. This is the probability of this probability of limited damage and how much year, because we here we are per year, so it will give you because per year, okay. Now let's suppose 0.8 0.0085 per year. Now we need to convert this to years, okay. This much damage is occurring per year, but now we convert it in how much year this total damage will occur, okay. Now we need to divide, because if it's per year we need to equal to 1, so year will go downside, it will go downside, we need to exchange with each other, okay. So this is simple mathematics. So it will give you 118 years if you install this system with this much probabilities, okay. This probability, and this is the chances of fire, and the sprinkle fire alarms and fire detector have this much probability of success. Then this event limited damage will occur in 118 years, okay. Now we will come towards the other way, this one, okay. So this, let's suppose in contrast the sequence, okay, not detect, okay. Then we need to multiply the other things. If someone has calculator, he can calculate this. Then 1 divided by the same. So let's suppose if you have this one way, okay. So here the sprinkle probability is more. So if the extensive damage occur, and you have this system with this much probabilities, okay, probability of success, then this extensive damage will occur in 2000 years if you have this system with this much specifications, okay. Clear?
Yes, quantitative. Yes, clear.
Okay.
Yes.
And same for the other things here, okay. We can calculate only, this is only simple calculation. We will go for this way, it will give you 0.0094 per year. If you want to convert it per year, then 1 divided by 0.09, it will give you 1063 years, okay. So if you have the system with this specification, so this damage will occur and this much years. If you have this specification, so this damage will occur and alas.
Yes. It means that you have to calculate each of your drawing, like fire detector, fire alarm works, probability. Then you have to be limited damage. Then you have to be multiplying it and divided by then into
Yes.
years.
Now, yeah,
Okay.
it's depend upon, the, let's suppose you have this system, but this system,
Okay.
this year is according to this 0.1.
Zero zero
Maybe
one. Yes.
your, yeah, maybe your company have 10 time of fire, okay.
Yes. Yes.
That your company, maybe in the last 1 year, 10 time fire occur in your company, and
Yes.
you multiplied here, 10 system works, okay. Then you need to 10 per year, okay. But this is according to this system, because this is very less, okay. 1%, okay. So the chance is 1%, probability is 1% only. So if your company have uh, 10 time
10%. Yeah. Yes.
fire in your company, or 1 per year, yes, 1 per year, let's suppose if it's 1
One
per
year.
year, then it's also
Yes.
too much, because here is 0.01, okay. So the
Yes.
system will go 100 time more, okay.
Hmm.
Let's suppose if it's 1, then we need to come here 1.17, okay, because you need to
Yeah.
multiply it by 100. If you are multiplying here by 100, so it should also be multiplied by 100,
Yes.
divided by 100, sorry. So it will come 1.17 per year, okay. And maybe
It
it will come 10 times, 10 per year,
it
okay.
means,
And
yes.
it will,
It means
yes,
if the probability is increased, then and your system is not working properly, then the number of years or a number of damages will occur more, and number of years may be
Definitely,
reduced.
definitely,
Okay.
definitely. Yes, because this is all related with this one. If there is too much chances of this mean in 100 year one fire occur. Okay,
Yes.
this one 0.1 per year mean in 100 year one fire occur. Okay, so
Yes.
that's why
Yes.
it's 117 years.
Yes.
If your company have one fire per year, then it should be 1.17,
and
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 it will
Ishfaq
be
bhai, and the probability is equal to 0.01 per year, and same like that the organization has set or are decided by the after the statistical data of is occurring of fire. Like if a company has a 10 per year, if a company has a 20 per year, then the same apply the methodology, and in the end we will see the results.
yes,
Is
yes,
it right?
yes. It depend upon the statistic of the company, okay, and the
Okay.
previous study. Because if
Okay.
someone is installing this system, they are definitely the fire alarm system. Let's suppose they will definitely see your environment, because we were studying that what type of fire system you will install in your company. There was how much system. There was one remote, one was this I forgot the names, which I already discussed with you, but there are
Yes.
four
Yes.
five systems. Okay, so
Yes.
that system depend upon your facility, your work environment, etc. etc.
Okay.
It's clear now.
Uh, yes. Yes. Clear. Clear.
Okay, so this is the simple another example for the heat detector system. But I think no need to discuss. It's a simple system, conveyor belt. Okay, the conveyor belt, the heat sensor works or not. Okay, if the heat sensor works, the probability is 0.9. If not, the probability of failure is 0.1%. Mean, okay, then let's
Mm.
suppose if there the heat is detected, the wall of this conveyor belt works or not, then the probability is 0.8 and the failure rate is 0.2. Okay, if the wall operate, the water spray start, one does not start. So 0.7 and 0.3. What is the outcome frequency now? Now you can go from here to here. Okay, here it's 2 for year. Okay, now see
Yes.
there here this 1,000 year and 20,000 years. And now see here it's 2 for year.
Mm.
Maybe some cement industry or some other industry. Now
Yes.
see this system. This much damage will occur 1.08 per year. Okay, here maybe
Mm.
half a year. Okay,
Yes.
okay, and
Mm.
here see. Okay, now
Yes. Yeah. It's nice.
maybe
Nice
this
system.
is happening
Okay.
after 2.5 year. This much event will occur because there are two fire,
Mm.
so four fire will occur in the next 2 year. Maybe six fire is
Mm.
occurring in the next 2.5 year. Okay, so maybe there is a chances that in one event this water spray did not work. Maybe the water spray failed. Okay, so maybe in the six
Mm.
chances there is one chance that maybe this much damage occur.
Mm.
Clear
Okay,
now?
Ishfaq bhai, yes, we you are you remembering that we study one question about top-down approach or down to top approach? Is it lies in these studies as up or
Yes,
fault tree
yes,
analysis
yes,
or
yes, yes,
top-down
yes,
or
yes. I
okay,
will show you one.
okay, okay,
And that is mentioned in the Raja board that what is top down and what is.
okay,
Now see, this is fire, this is the top event. Now this is
yeah,
top down. You will come from the top to down, then fuel,
yeah,
then paper. So this is top down. Okay.
okay,
Here in this system, this is top down. You are coming from top to down. Okay.
yes,
This is fire. After the fire, you are going upside. What is it? Because our our intention is to control this damage. Okay, this is our final stage. So now you are going from this bottom up. Okay, you are going bottom up. This is the
Yeah.
final consequences, and this is, you know, from this point to this. Okay, this is a deductive. Okay,
Yes.
remember what I think when this is deductive. Deductive go from general to specific. Okay, now this is from general to specific.
Okay.
Okay, and the other should go from specific to general. We will discuss
Okay.
this, you know, here. Let's suppose here preliminary hazard analysis. Can we discuss this one, or we should skip this one? Okay, here something is remaining. We need to discuss that also, because that cut set is very important. There is one example mentioned. We need to discuss that. Okay, the limitation of faulty analysis. What should be the limitation of faulty analysis? Maybe all the events we did not, identify. Maybe there is a chance that the people are incompetent. Okay, so this type of chances are there. Maybe some events are oversight. We did not. Maybe some event we did not give importance. Okay, so this is the limitation of the faulty analysis. Okay,
Okay.
I think we know no need to discuss this. Maybe this is all. Maybe people don't have the knowledge. Maybe the event we did not identify.
Yeah.
Maybe some event we did not give importance, and that event, this undeveloped event. Undeveloped event mean we don't want to discuss that event more. Maybe we just ignore one event. We are not discussing. There is an event, but we don't want, because we don't have knowledge of that one. Okay, that is called undeveloped event. So that undeveloped event, we will not extend furthermore. Let's suppose if there is any event, we will just give you this diamond, and that diamond will not go further. Okay.
Yes.
So this is the limitation of the faulty analysis. This out and in. Out, this diagram, should you remember this one? It means that the page is finished. Okay, and this one branch is going to another page. Okay, so we will just at the last stage we will just type out. Okay, out, then next page in. Okay, from that in we will start our tree.
Okay.
Okay, uh, we'll just discuss some this logic gets we discussed. Okay, and primary failure and secondary failure. Primary failure are those failure which is occurring inside the, um, let's suppose components. Okay, which is occurring inside the component. Okay, your component is failed. This is your primary failure. Secondary failure mean the failure which is occurring outside the environment, due to the environment. Maybe some corrosion occurred to your equipment. Okay,
Okay.
that is secondary failure due to some secondary reason. Primary mean which is happening inside the component, and the component will become inoperative. Then it's not working. Okay, maybe some circuit failure, maybe, because this is electrical component, so it maybe it's not, maybe the wall is failed itself. Okay, so this is primary failure.
Oh,
Secondary failure may be due to humidity, the wall is damaged. Maybe some
oh.
vehicle damage the, wall. This is secondary failure.
Due to the environmental conditions or
Yes,
uh, s-
yes,
like that, secondary failure. Yes.
yes. External problem.
Okay.
Due to external problems,
External
that is
problem.
secondary. Yeah, maybe environmental, maybe some, etc., etc. Okay.
Yes.
Okay. Primary faults and secondary faults. Primary faults are that abnormal events within the system which is occurring. Okay. Let's suppose your company, your equipment failed not to work. That is inside the equipment which is occurring. Secondly, you will can say that, let's suppose you press the knob mistakenly, and your equipment, your system fail. Maybe you switch on the button mistakenly, you didn't see and you switch up that, okay? So that is secondary part. And primary parts which is inside the system.
Okay.
Okay.
Yes.
Now, give me 1 minute, okay? We will go for the cut sheet. This cut sheet is very important, and in the last two exam, I faced question from this. What is the cut sheet? The minimum cut sheet. This is visible to you people.
Yes.
Cut sheet are the minimum events are the probability due to which the output event is occurring. Okay.
Okay.
Clear? The output event is occurring. We need to calculate the minimum probability for that. So the minimum probability for the minimum cut sheet will be the minimum probability of that event which is occurring. Here I will just explain to you. Maybe it will be very easy to you. Here, let's suppose we have this system. This branch only. Okay. Tell the B. You are not going for the other. Okay. Tell B. This is same file, but this little bit they explain more. B event. This is OR gate. This is AND gate, and this is AND gate. Remember, for the OR gate, we need to do what? We need to add all these three things.
Add.
All
Add.
the three. Okay. For the
Yes.
AND gate, we need to multiply the
Multiply.
input events.
Input.
Okay.
Yes.
Now
Yes.
for the B, D, E, F, either of these three occur, B event will occur. Okay.
Yes.
For the E, J and K, combustible, leak into the storeroom. Okay. For that, what will happen? We have one storeroom. Okay, and the storeroom fire occur. Okay. So for that,
Yes.
we need combustible material. The combustible material is coming from where? From the combustible store inside. Maybe the combustible some leak, maybe some cylinder is leak. Okay, maybe some petrol can is leak, etc. Okay, our stock material degraded. Okay, this is the reason. So for the combustible leaks, maybe the fuel source is adjacent to the storeroom. Okay, maybe leakage pathway to the storeroom. Maybe there's some external other leakage which is coming to the storeroom. Okay, so this is AND gate. For the AND gate, we need to multiply the events. Okay, here we need to multiply it. We will multiply this, it will give the result here and will give the result here. So this result and this result is same. Okay, after the event and before the event, it should be same. Okay.
Yes.
So F, E, and D. After this means either of this event occur, the combustible material storeroom mean the
Occur.
combustible material will be available there. Okay.
Available.
Now
Yes.
see. Now see here. D, J, K, L, M. It's given here. The frequency and days. Okay. Probability for the events is given. 3.45 multiply in 10 raised to power 7. 6.89 multiplied 10 raised to power 4. 7.3 multiplied. Okay. And this. Clear? This is for
Yes.
D. D is given directly. D is here. See, D is here. Okay. No need to go downside. D is given directly. We need to calculate E and we need to calculate F. For E, we need to calculate J and K. We need to what? Multiply.
Add.
Here we need
Sorry.
to multiply.
Add. Multiply. Yes.
Okay, this is AND gate. For AND gate, we need to multiply. JK
Multiply.
and LM. Okay. So JK, okay, probability of J and probability of K. It is 5.05 multiply 10 raised to power 6. Probability of event F Where is F? F is here. Here is the AND gate. So we need to multiply L and M. L and M. Probability of M and probability of L. We need to multiply. It will give you this value. And D is directly given. D is what? D is 3.45 multiplied. Now see, where is the probability is more? In which this is bigger, this is bigger, this is bigger.
Actually, 10 raised to power minus 7 less is
Yes.
not.
So
Yes,
this
yes,
is less. We will exclude this.
yes.
We need to see in this other two. Now we need to decide in these two. Where is
Yes,
the
5
probability
point.
high?
Yes, high power
Yes.
5.05.
Yeah.
Yes.
So 5 point mean here. Here the probability of this B event is high. Maybe this event occur because this event is occurring as compared to other two event more. Okay. So this have the minimum cut rate for this B. Okay.
Yeah. Yes.
Here the chance is more here. So maybe the
It
event
means
is occurring this.
it means that every event has some cut sets.
Yes, every event
So
have the cut rate. Okay.
cut sets.
This one
Okay.
also have, this one also have, and this one also have. Okay.
Yes.
But now we
Yes.
need to decide where the probability is high.
Yeah.
So
Okay.
read the example first. What the example say? For the fault T in figure 3.5, the probability for some of the okay, this is not example. Okay, here. What is the most likely cause for the event? Okay. Now they will ask in the question. They will, and this type of question they will give you. What is the most and what is the less? If they are asking for the less cause, okay, less likely cause, then it should be D. But most likely cause, then it should be this cut set. Okay.
Yes. Yes.
Now it's clear.
Now it's clear. Yes.
So this was all related to the fault tree analysis.
Okay. And Ishfaq the FME is also
Yes.
related to this.
Yes.
Related to like
Failure
that.
mode effect. Yeah, the same
Yes.
here. I will just discuss with you. Failure mode analysis, same like the risk assessment. Okay.
Okay.
But here only the terminology is a little bit different. Same, because we are using this same type of form for the risk assessment. We are identifying the hazard and etc. But here we will identify the failure mode. That what is the failure mode? Here we will just identify the component. Let's suppose we have one pump. Okay. And what will be the failure mode? How it can be failed? Okay, maybe someone did not switch on the pump. Maybe the pump have some internal damages. Okay. Then
Yes.
what will be the causes of that failure? Now it depends upon your system. Maybe you need continuous water, and if the water stop, the fire will occur. Maybe. Okay, these are just example. Maybe if the flow is stopped, maybe your reaction disturbed, and it's possible that sometime you need continuous streamline. If it's not there, maybe explosion occur. Maybe the pressure inside the other stream flow is increasing. Maybe fire can occur. Any out. This depend upon the system. That what will be the outcome. This we are just discussing the supposition. Now that failure. Now let's suppose if any failure occur and cause is also there. Okay. Now it affect the other components. We will just discuss that. Let's suppose this failure mode is occur, the pump failure occur, and this is the two causes. Maybe the pump is damaged, or someone switch on the switch off it deliberately. Maybe there is no power, so this is the chances. Maybe some mouses or some other things, animal cut its wire. Okay, this is also
Yes.
one cause of the. Okay, we need to discuss, identify all the causes related to that failure. After the failure, we need to check that what is the effect of that failure, okay, on the system, the components, and the person which is involved in that system.
Okay.
Okay. And the
Okay,
same, this
Ishfaq bhai,
is what
please,
is the,
these are the standards, or maybe the effects
yes, this is the standard form.
can be can be changed on, maybe on environment, maybe on equipment,
Yes, yes.
maybe.
Effects
Okay,
can be changed. It's depend upon your system and environment.
okay, okay, okay.
Okay, because this is not a universal thing. That maybe some equipment, some things are in one environment works, and another environment does not work. You know, we were
Okay.
installing this solar panel in Almarai. If Mushtaq is here, he will know. So once the temperature of their solar panel, let's suppose, because here in Saudi, the temperature, is too much high. And for the solar panel, you need cold and not completely cold, but the temperature between 23 and 35 till 40. If this is your temperature and the environment is clear, there is no dust in the environment, then it will give you the full efficiency. But here in
Hmm.
Saudi, also the solar panel is black, so once the sunlight is falling on it, also it's black, so it completely absorbs the lights. The temperature was 65 and 67. Then the efficiency of that solar panel was very reduced, and there was too much big problem. Our project timeline was April, and then we
Hmm.
hand over in September.
Hmm.
So some equipment, it depend upon the environment. It's working properly, and some environments not working properly. We designed for
Okay.
that some switch gears, etc., etc. So they take all the parameters of the Saudi, environment, dust, sandstorm, temperature, and for that, there was one company they designed the switch gear for that. So this factor should be considered.
Okay.
Spare mood analysis is very easy. It's not for that. This is the specific farm. Okay,
And it is
this farm should be.
also in qualitative and quantitative, or a simple qualitative.
This is a qualitative.
Okay.
Hmm. Because you need to write here the statements.
Okay.
Okay. Any
Yes.
question?
No, it's very nice. No.
So I just become very tired. Even I cannot talk more.
Okay.
So if
Okay.
you have
So
some question, you have some discussion,
yes,
we can discuss it
uh,
now.
yes, it's nice. And one thing is that we have to be, and the question may come from this all the methodologies which are we are discussing, which we discussed today. So I think
Yes,
is very comprehensive, and I think there is no big issue to resolve the question, uh, even if you are in the last you presented about the cut set as well. So I think it's easy, very easy. So there is no
yes,
need
and
to
generally they
confusion.
will, yeah. In the exam, they will ask about the gates,
Yes.
and they will give a
Mm.
simple branch like this, only this branch, okay? And they will
Yes.
ask you that what is the, uh, mm, you know, least likely or most likely probability of A.
Hmm. Yes.
Hmm.
Yes. It's very nice.
Now it's clear?
Yes, Ishfaq bhai is very nice. Thank you very much, and
Yeah,
Jazakallah.
well,
Uh, Before this, we don't have any serious concept about that. We have a little bit, but now is fully gear up.
yes, now if you study it by yourself, then it will be very clear.
Yes, yes.
Because I just discussed only, uh,
Mm.
the items which have huge weight. Other things, many of things which I skip. So if you study it by yourself, you will get more knowledge now.
Yes, yes, definitely. But the basic concept is clear now. What
Yes.
is poultry, and why we use, and like that.
Mm.
So
So can we wind up it now?
yes, for today,
Because no
and
one has.
our no assessment is pending, but tomorrow I think there is a holiday in a week. So
Yes.
but Mushtaq Shaikh has decided with Abdul Latif Bhai about the session. So maybe I will not come, or maybe Asghar Bhai, I don't know, Asghar Bhai will come. So it is repeated. So I request to Mushtaq Sheikh and Abdul Latif Bhai, maybe take it on a Monday, and before the 8 p.m. we will start, and Abdul Latif Bhai conclude it in an hours. Then we will start the our assessment, pending assessments. So it is my request. Otherwise, if it is duly need, then we will start tomorrow. So Mushtaq
Okay.
Sheikh, what will you ask about that? Then we will hang off for today. Mushtaq Sheikh, bhai, are you there? Okay, now we will hang it now today. But
Okay.
for the tomorrow, we will just in the evening. I will confirm from the Abdul Latif Bhai and Mushtaq Sheikh. Then we will send a message to the safety Newton, and then we will do as both are agreed, or like that. Okay. Otherwise, there will
Okay.
be a no session. There will be a holiday tomorrow. Okay.
Okay.
Okay, Ishfaq bhai, so nice of you. Thank you very much.
You're welcome.
God bless you. Take care.